Hi, my name is Rick, and I'm an engineer here at DeltaStream. Today, I'm going to give you a preview of the DeltaStream AI agent that we've been working on. I'll walk you through how we can use this agent to build a complete streaming pipeline using natural language. Specifically, I'll show you how the agent understands your data, generates the necessary streaming logic, and deploys a working pipeline, all with minimal manual effort. So as you know, agents are quickly becoming a powerful way to simplify complex systems, and DeltaStream is no exception. The key idea here is that instead of writing SQL statements or manually defining streams and changelogs, you can just describe what you want in plain English, and the agent handles the heavy lifting for you. And the reason this is so powerful is that building streaming pipelines today typically requires a pretty deep understanding of both your data and the underlying system. You have to think about schemas, joins, windowing, and how everything fits together. What the agent does is remove a lot of that friction. It lets you focus on the outcome you want instead of the steps required to get there. And ultimately, the goal isn't just to build pipelines for the sake of it. It's to deliver real-time context that other systems and agents can use to make better decisions right now, not minutes or hours later. So let's start off with first looking at the data we're looking at for this demo. So we have two Kafka topics sitting on an existing store. On the left, we have a page views topic. This captures activity with a view time, a timestamp, a user ID, a page ID. And then on the right, we have the users topic, which is a little bit richer of a topic. It has user profile data, including region, gender, interest, and most importantly, the contact info also contains a zip code. The thing to notice here is that both topics share a user ID field, and that's our join key. This is what lets us enrich the raw page view events with the user's profile data. And down on the bottom is the prompt that we're going to give to the agent. We're telling it in plain English. I want to create a pipeline that enriches page views with user data, writes the enriched data to a new topic, and then builds a materialized view that shows page views per zip code per minute. And that's it. One sentence, and let's go ahead and take a look to see what the agent does with it. So this is the architecture that the agent will generate. I've done this some number of times. On the left, you can see our two Kafka topics, page views and users. Those are feeding into DeltaStream. Inside the DeltaStream boundary, the agent creates two queries. The first is an enrichment query. This is a create stream statement that joins page views with the user's changelog, and then it writes the enriched result into a new topic called enriched page views. That enriched topic then feeds into DeltaStream into a materialized view query. This applies the 1 minute tumbling window, groups by zip code, and counts page views. The result is a materialized view that is now queryable in real time. And that's where everything comes full circle. That materialized view becomes real-time context that any agent can query. You can see the AI agent box straddling the DeltaStream boundary because this could be your own agent, or it could be the DeltaStream agent itself. Either way, instead of scrambling to join 5 streams at decision time, the context is pre-computed, always fresh, and ready the moment the agent needs it. So the agent figures all of this out, the schemas, the join logic, the windowing, the output destinations, just from one natural language prompt. So now that we've got that out of the way, let's go ahead and jump into the demo. Okay, so we'll get rolling on the demo here. So as you can see, I have the DeltaStream CLI up and running. This /agent drops us into the agent mode. And then I'm going to launch the prompt that we had talked about before. So it says, I want to create a pipeline that enriches page views with user data, writes that enriched data to a new topic, and then builds a materialized view that shows page views per zip code per minute. The cool thing is, I didn't tell it anything about page views or user data. It's going to query the system and figure this stuff out as we go. So if you notice, there's some of these execute DSQL commands. That is the agent invoking tools on DeltaStream to figure out the state of the system. Right now, we're doing some print entity operations. So the agent is sampling data on these topics so that it can then understand what the schema looks like. So as it turns out, the users topic, the agent stumbled a little bit there. Users is a DeltaStream keyword. So after seeing the error, it references some of the documentation and then goes back and tries to do that operation again. Okay, from there, the topics have been inspected, the agent understands the shape of the data, it's going to come up with a plan that it's then going to execute to create this pipeline for us. So you can see it's going to create a stream that describes the page views topic, and then the same for the changelog. It is asking, do you approve to run this create stream statement? The agent asks for permission anytime that it's going to do some sort of a mutation to your system so that you are in control at every step along the way. So here we'll go ahead and we're going to create the change logs. We're going to say, yep, go ahead and do that. And next it's going to create our join. So this is going to create the enriched stream, and it's going to ask for permission there again. So this is launching a long-running query in the background that's processing data as it's flowing into your Kafka topics. And it stumbled again, so we'll go ahead and say, yep, go ahead and try it again. And that was successful. So now we are creating the materialized view. And this is where the tumbling window will be applied to compute the 1-minute aggregates, specifically page views per zip code. And we'll go ahead and say yes there. So now that everything is complete, the agent provides a summary of the plan that was just completed. As you can see, the agent defines schemas for the existing topics, the enrichment step, and finally the aggregation into the materialized view. To validate these results, I can query the materialized view and see the real data coming through, showing those per minute metrics. Okay, so now let's go ahead and ask the agent to show us sample some of the data. Sample some of the data from the new MD. And it says, let me query the materialized view for you. And it's going to go ahead and grab some of the rows. And it says it's not quite there yet, so it's going to actually go and check to make sure the query is indeed running. It just looks like there's not data there yet, so we'll just give it another minute. And this time we have some data. So there you go. You can see that this is processing as the results are coming in. Okay, so now that we've gone through the demo to show you the power of what the agent can do, I want to show you what you would need to do manually if you were doing this without an agent. So first off, you'd have to declare your page view stream and your changelog stream. So you'd have to go out, inspect the data on your topic, understand what are the different field names and what are their data types. And then you would need to create a long-running query that is joining page views and users together and then writing it out into the enriched topic. And then you would have to create the materialized view that is going to do the tumbling enrichment and then writing out to the materialized view. So while this isn't terribly complex, if you are a streaming expert, if you're not, it's sort of a tall ask. So what this demonstrates is super powerful, right? Using only natural language, we took a fairly complex streaming use case where we are doing a join, enrichment, aggregation, and then materializing it. It only took a single prompt to do that. So I want to highlight these three key pieces. First, you can describe what you want in plain English without needing to know DeltaStream or knowing streaming concepts. Second, the agent understands your data, discovering schemas, building a plan, and generating the right queries automatically. And third, it delivers real-time context that your agents can actually query, pre-computed, always fresh, and instantly available. No more assembling context at decision time from 5 different systems. That's the real power of this approach. It dramatically lowers the barrier to building streaming pipelines, streams up development time, and makes these capabilities accessible to a much broader set of users, not just streaming experts. Instead of spending your time wiring everything together manually, you can focus on what you actually want to build and let the system handle how it gets done. To learn more about real-time context for AI agents, visit DeltaStream.io. Thanks for listening.